So thanks for the introduction. I think I should start my show. Hi, I'm Martin, and yeah, today I want to talk to you about boot, and boot is, yeah, what it is I will tell you later. So basically the talk is split into two parts. The first part is going to be about what boot is, why it exists and how it works. And the second part is going to be a bit more hands-on demoing how you can use boot and showing how to extend it. So what's boot? Boot is, as the title of the talk, I guess, indicated, a build tool for Clojure and Clojurescript, actually. So it's very similar to Leiningen. I don't know, I guess most of you are familiar with Leiningen. It's the de facto build tool for Clojure, I'd say. And yeah, so boot solves kind of the same problems as Leiningen, but in a different way. So the question is, why another build tool? Like, we have Leiningen, and Leiningen is actually quite amazing. Like, when I came to Clojure, I was amazed by how simple like build tooling can be. It's just a declarative map of things you want to do, and it's very straightforward. You easily understand it, and it's just very easy to use. So before I want to answer the question why there should be another build tool, I want to provide some context around that. So initially, boot was created for a system called Hoplon, and Hoplon is a system for building web applications. It has a back-end part and a front-end part. So it combines Clojure and Clojurescript in like a full-fledged package to create web applications. And creating web applications was very much focused on Clojurescript as well. So they developed a language called HLisp, which looked kind of like this. So basically it's HTML, but outside of your general HTML type stuff, you have a script tag that contains Clojurescript. And so the intention behind this was that designers and other people can easily use this sort of model to change applications and to contribute to the development process. So this kind of new language or dialect of HTML, you could say maybe, required an extra build step. So basically everything you can see here compiles to Clojurescript. Even that HTML part at the bottom is compiled to Clojurescript. And then it's delivered to the client and will actually render all that the complete page you can see here. And compiling things in like multiple steps, like compiling the HLisp you can see here to Clojurescript and then to JavaScript, isn't exactly what Leiningen is very good at. So initially, they created something like Line Hoplon, which helped them with that, but quickly figured out that Leiningen doesn't really provide abstractions to reflect more complex build processes. Like if you want to do multiple things, like you want to compile CLJX, I hope everyone is familiar with CLJX. It's like small language to compile to Clojure and Clojurescript. If you want to compile to CLJX to Clojure and Clojurescript, and then want to compile the Clojurescript to JavaScript, there was no real pattern to sort of do this two-step process. And so with this discovery, they sort of decide, okay, let's write our own build tool. And they write boot 1.0. And a lot of time passes. Boot 1.0 is used in Hoplon with great success, I believe. And generally allowed them to come up with a much more easy entry point into the development process. So just recently, they released boot 2.0. And actually not 2.0, but release candidates of 2.0. So 2.0 is not really released yet. And 2.0 is a complete rewrite of boot 1.0. Provides a bunch of new abstractions and features to sort of suit all your build tool needs. And that's also when I discovered it. So I actually never heard about boot until they released version 2. I actually also never used Hoplon. Yeah, so that's the why part. And now I would like to continue with how boot actually makes this so much more straightforward to build your Clojure and Clojurescript applications. So similar to Leiningen, boot has this concept of tasks. And tasks are basically, this works too, an abstraction for all your build processes. So in Leiningen, you can do line jar and line uber jar, and these are tasks. But you cannot do line CLJX, CLJS, and I don't know, some to CSS compile language. And so that's what tasks in boot are trying to solve. And so tasks in boot are basically the unit of composition you can use and you can utilize in your build steps. Basically, tasks also try to encapsulate everything you would potentially want to do in a build step. So let's take a look at how those tasks work and what they actually look like. And for that, I brought a small snippet here of a build.boot file. And the build.boot file is conceptually similar to a project CLJ in a Leiningen project. Is everyone familiar what the project CLJ file is? I hope so. So at first, you can see a set environment function call that basically defines some source path and dependencies, which is very similar to what you do in Leiningen. Like you specify some source paths and dependencies, but you do it in a declarative way and not in a almost imperative way like this. And then you require some things, very basic Clojure stuff, I guess. And then you define a task called run. And run is basically the entry point to run your application. So you compose all these tasks you can see there with each other, making them a new task that you can then call. You serve files, you get some audible notifications when your build completes. You watch the file system to trigger new builds whenever that happens. You set up a Clojurescript REPL so you can connect with a Clojurescript application live in the browser. You initiate some fig wheel style reloading, so whenever you change a file on your computer, it is reflected immediately in the browser, and then you eventually build your project. And so that build task is actually just another task that is composed from other tasks. And so the build task compiles our CLJX, which I mentioned before, then compiles CLJS, and then compiles our garden style sheets. So here we can see very nicely that we can easily compose tasks with regular function composition. And that basically allows us to just compose all the build steps we could potentially want to do. And that's really awesome. So how does this work? Like how can we compose things that actually modify the file system? And basically the concept of tasks is very similar to Ring middleware or middleware in general. But I don't want to go too much into detail about that. You can read a lot of good documentation about that in the boot wiki. But what I want to address is two concerns that could come up in that context. So one very valid concern is that there are side effects everywhere. So every build task you want to do eventually will emit a file. So you compile Clojurescript, you get a JavaScript file. You compile some Clojure-based CSS to CSS language, you will get a CSS file. And all this basically mutates the file system. So how can we compose these things without like ending up in a giant mutable mess of like mutable state, which is something we always want to sort of avoid in Clojure. And Boot's answer to this is the file set. And the file set allows us to pass all these files that are emitted by build tasks as values to another task. So we're not actually like, one task doesn't wait for the task before it to write something to disk, but instead it gets a list of descriptive data structures about the files it should get. And all these files in the file set are isolated from each other through temporary directories that are managed by boot. So you can't really overwrite a file, but you can change the pointer to a file. And that's actually quite similar to how persistent data structures work, I believe. So at the end of each task, you basically, or in the beginning, you get a file set in a task, and then you generate some new file, and then you create a new file set with the information where a new file is, and the information in the old file set, and that new file set is then passed to the next task. So actually, you don't modify anything, but you're just passing immutable values from task to task, which makes this kind of composition very straightforward. And so with this kind of composition, obviously all of the things need to run in one process, and then we run into a whole other problem, which is dependency isolation. So if we want to compile something, or we have two tasks, and one task requires version 1 of certain dependency, and the other one requires version 2 of a certain dependency. So how do we make this work? Like, this is not what should be a problem. And Boot, there's a concept that's called pods, and pods are basically a solution for the problems that arise from running all the build steps in one JVM. In Leiningen, you don't have this problem because all the tasks run in separate JVMs, which is good and bad, I would say. So pods are what Boot provides you with to isolate dependencies. Basically, pods are a system to get isolated Clojure runtime. So you can get a Clojure runtime with a different class path than whatever Clojure runtime you had before, with different dependencies, etc., pp. So you really get sort of isolated Clojure instances, you could almost say. So that's almost my what, why, and how part of the talk. So before we dive into the more practical stuff, I want to quickly talk about two more quick things, so that the stuff later on makes sense. When you invoke tasks from the REPL, you can wrap them in a boot macro, and you can pass task options to tasks. So to influence how a certain task behaves, there are options. And in the case of CLJS, you might want to pass different optimization levels to the compiler and whatever. So there's some way to influence the behavior of tasks. And then another thing, which is I think also a really nice feature, is that there's a symmetry between how you call tasks in a program or in the REPL and how you call them in the command line. So what you can see here is a task or a boot invocation, which is actually in a shell, a boot serve watch CLJS optimizations advanced. And this is completely identical to the one below. So you get this kind of symmetry for free, which makes it really easy to experiment with tasks and to just play around with options and do whatever you feel like. Okay, so now I want to give you a quick demo of what it looks like to use boot in a Clojurescript project. And yeah, so that's what's going to happen. Let's see if I can make this work. Computers. Amazing. So I guess I should mirror this now. Mirror displays. Oh, great. All right. So here we go. I already created a new application. I called it clojureD, how fitting. And I quickly want to show you what the build.boot, which is the same as the project CLJ file, looks like in that project. So the build.boot file looks like this. So we set source paths, we define some resource paths, we specify a bunch of dependencies that also import tasks we will use later on. We require a bunch of stuff that's required in our build script, and then we define a build task and a run task very similar to the example I showed you earlier. And below we have two other tasks, production development, that influence how these tasks are then actually called, so we can build them for different environments. And at the end, there is a small task, def, which basically just is an alias for development run. So if I now call boot def, that's actually the same as calling boot development run. It's totally identical. So let's call boot development run and see what happens. This will take a long time because we're in the JVM. No, it's actually not the JVM's fault. I don't know if you, it's interesting, I learned that, and I can tell you now because we have 40 seconds of time. Starting a Clojure application isn't slow because of the JVM. That's basically a myth. And starting a Clojure application is slow because Clojure is so big. Basically, that's the answer. So yeah, I learned that just recently, and that was actually quite interesting. Okay, so I should have talked longer. All right, anyway, so what we see here is like a bunch of stuff happening, a bunch of like an nREPL server started, a WebSocket server started, an HTTP server started, a bunch of files are getting compiled, and now we're done. It took 37 seconds, I can't believe it. All right, so now we can see here localhost port 3000. Whoops. All right, great. That's big. So we're loading that page. It says hello world. And now let's jump into more of the project. So let's take a look at the app CLJS file. And what I think is very important to notice here is that this is the only Clojurescript file in the project. So there's nothing else. And it doesn't contain anything that is specific to what I will show you next. So it's really just our application. And now let's say I change this to hello clojureD and save it. And then I go here and it's immediately transferred. I didn't press command error or something. And that's a workflow that's becoming a lot popular in Clojurescript land, so to say. And that's also really nice. So another thing that just comes for free with the boot tasks we used is a REPL. So here we see an nREPL server has been started on port 56960. So let's connect to that one. 56960, I hope that was correct. All right, so now we're connected. So what we can do now without influencing our actual application source code at all, so we can start a browser REPL. Start REPL. And that gets us into a Clojurescript REPL, which allows us then to evaluate Clojurescript in the running application in the browser, which is not new, but still awesome. So let's alert something. Great, that didn't work. Let's try it with logging. I might be wrong with my interop. All right. So, thanks everyone. So, boom, and there we got an alert. Isn't that awesome? So, as I said, I think the really interesting part here is that all this is achieved in tooling. It's nothing you have to put into your application, nothing you have to sort of worry about. You can reuse these parts, you can share them with others, so you don't have to actually maintain them yourself. And I think sharing this kind of tooling is really essential to improving it. Yeah, so another thing I wanted to show here is that when you change different files, not the whole application is recompiled, but if you change a file that only compiles to CSS, for example, as this file does, only this file is recompiled to CSS, and none of the Clojurescript stuff is touched again. So that's also really nice, this sort of partial recompiling of or rebuilding of your project. All right, so that was basically the demo. Now I have to figure out how I get back to this. Okay, so that all worked great. Okay, so so far the demo, I hope that was impressive or entertaining at least. And what I would like to cover next is like how to write an actual task. And I think what's great is that this is actually quite easy. Like I picked up boot, and 3 days later I was, or I don't know, the same day maybe, even with the help of all these kind people in IRC, I was able to write a task. And so I just want to walk you through one of the tasks I wrote that compiles Garden to CSS. Garden is basically a Clojure library that allows you to compile stuff to CSS. I mentioned that before. All right, so what you can see on the right is basically what we're going to walk through now. And it's 50 lines of code. And that's all that's required. For comparison, the line garden task has 250 lines of code. Not to brag, but that was kind of interesting to see. All right, so let's start with the beginning of the file. It's quite simple, like a namespace form. We require a bunch of stuff that boot provides that we need. Also, we want to do some I/O stuff. I guess that's fairly straightforward. What we're also saying is we want this task to be available in our build.boot file. So I guess that's clear so far. And then we define initial, which is just an atom that says true. And we're going to use that to check if this is the initial run of the task. You will see why this is necessary later on. And now we get a quick example on how we can use pods. I talked about pods earlier, like they're isolated Clojure runtimes. And you can see here how pods are being created. And so the first function basically takes some environment that you can get from boot, which basically gets you the current environment, and add a dependency to that environment. And so in the garden pool pod function, garden pool function you see at the bottom, we actually create a pool of pods with a dependency added, and that dependency is garden. And a pod pool is useful to always have a pod ready when you need one. So creating a new pod takes a second or so. And you don't want to have that second during your building. You just want to have one laying around that you can get, so things go really fast. And the function in the middle is an NS tracker pod. I'm not sure if anyone has used NS tracker. Basically, you give it some source paths, and you can call a function, and it will change. It will tell you what namespace has changed since you last called that function. So we create a new pod with this NS tracker dependency, and then that's kind of nice, because this NS tracker dependency doesn't really have anything to do with our project, and it's not really good if we have it on our project dependency. So that's really a nice way to isolate this stuff from our actual application. And yeah, so I hope that's understandable. All right, and now we're actually going to create the task. What you can see here in the brackets is some sort of DSL for defining task options. And the first column is like command line single character arguments. The second column is the double dash sort of style to notate them. And then there are types for them and descriptions and all that. And I can show you that later. Yeah, and so we basically define some options. We want to say, hey, this is where you should save the file to, and this is the var where all my CSS is in. So you should compile this thing. And then we get into some let form. And that let form is basically contains things that we want to stay the same, or that we need for every task invocation, and that don't really change. So we default to some output path if none is specified. We generate a namespace symbol that we can then later use to track the namespaces. We create a temporary directory that is managed by boot, so it's just like some random descriptive, non-descriptive path in the file system. And we generate an output path into that directory. And then the source paths give us the source path in our current project as they are passed to setEnv you saw earlier. And then we create a garden pool, and we create the NS tracker pod, which are the functions you just saw here. So now we have a pod pool, and we have a pod to track namespaces, and now we actually want to define that function in that pod to track those namespaces. So in this NS tracker pod, we require NS tracker, and then we define a var that contains this kind of function that always sort of lets us know what namespace has changed since the last invocation. And yeah, so we can evaluate that function later in the pod. So what is boot prewrap? Boot prewrap is basically a little helper function to make it easier making your tasks conform to the sort of middleware approach that has been developed to compose tasks. So you specify a var which will contain the file set, and then we're checking, hey, is this the initial run of the task? So that's the atom you saw earlier. And if it is the initial run, then do this, or if the namespace that has been passed to this task earlier is in the list of changed namespaces, then we also want to run this code, right? So we get a new garden pod. The garden pod's refresh function basically gives us a new pod from the pod pool. And then if initial is still true, we want to set it to false. So then only recompilations are triggered by actually changed namespaces. And then we print some debug messages. We make parents of the output path so that we don't try to save to a place that doesn't really exist. And then we actually compile stuff. And this is another eval input function, which basically just requires something and calls a function. So you can see the namespace we specified where our style sheet is in. We want to require that. And then we call garden core CSS, which just allows us to compile the style sheet and save it to a location with all the options as they are generated by the options that have been passed to the task. So now that file is saved to disk. So we have it somewhere in a place we don't really know where, actually. And now we want to add it to the file set, because that's how it's eventually going to end up in the artifact that's built by the build process. And doing that is also fairly straightforward. You just add like another line like this, basically saying, hey, add this temporary directory to my file set and commit it. And committing basically just means, like, if this file already exists, change the pointers. If it doesn't exist, sort of merge it in. And yeah, and so since we use this boot prewrap function here, we don't need to actually call the next task ourselves, but this is handled by this boot prewrap helper. All right, so we're done. That's it. That's how you write a task. I hope that wasn't too intimidating. But yeah, I was pretty amazed by how straightforward that was. So before we come to an end, I'd like to show you a couple of resources that are extraordinarily useful to get started with boot. One is the wiki. It's like a really well-formatted wiki. It has a bunch of pages on like the high-level things like tasks and file set and pods and everything. But then also helps you like tuning your JVM options or setting up Cider to work with Boot's REPL or whatever. Like it's really a good place, a good community place. It also has a list of tasks written by the community. And so if you're looking for something specific, chances are you might find it in there. There are like, I don't know, maybe 30 tasks by now. And they cover most of the often used things and some compilers for esoteric languages. And another thing that I found very nice is the IRC channel Hoplon. I don't know if, has anyone ever been in that IRC channel? You're laughing, so you must have been, I guess. No, but like this is, it's a nice corner on the internet. Like, I don't know, it's the people behind Boot are really nice guys, and they're like super helpful and happily spend an hour answering your totally stupid questions. And yeah, there's also some sort of excitement around Boot, I guess, and doing things slightly differently than we've done them before. And yeah, so you should totally go there. It's a nice place. And another thing is Tenzing. It's a template I've been working on. It's actually inspired by Chestnut, so thank you. And basically it provides all the kind of features that Chestnut provides, or almost maybe, but implemented in Boot. And I hope that that's a nice entry point for people to play with Boot and to check out how it works. And I hope it works if you do. Funnily, you use Liningen to generate the application. So that's almost it. Just to conclude, I think what's great about Boot, or what's interesting about it, is that it basically gives us some sort of abstraction over build processes, and it really allows us to do more complex things than just one-step processes like building a jar. And providing these sort of abstractions is essential if you want to do anything more complex, and especially if you're using Clojurescript, you need multiple build steps. And having to run like 3 lining invocations for your project starts 3 JVMs and consumes a bunch of memory. So I hope boot is an interesting alternative to play with that. Or I found that boot is an interesting alternative to that. And yeah, I guess that's it. You should all give it a spin. Thank you for coming. And are there any questions?
Okay, so with the multiple line again invocations, are you able to just use aliases in a lot of those cases? With
Excuse
the
me?
line again aliases
Yeah.
to go do this, do that, and also in conjunction with trampoline to stop the JVM starting multiple times. Is there like a lot more that, like, we just touched on some of what it does, but does it do a lot more than just that at the most basic level?
Excuse me, could you repeat that? Like the line do allows you to invoke?
So line again has, as well as like line test, line run, those kind of things. You can chain together multiple commands with line do, and do this, line run, line clean, line compile, those kind of things. And you can also combine that with aliases inside your project file to create aliases to say rebuild is going to be compile, clean, and those kind of things.
So how that compares to boot, or why one is better than the other or something? So I think one problem you have with line do is, which is a very big problem, I believe, is that there is no sort of generic watch task you can do. So whenever you do something like line do CLJX, CLJS, it's a one-off. So it compiled CLJX, then it compiled CLJS, then it's done. But that's not how you want to develop, right? Like that's you want to incrementally compile your stuff, and you want to do it fast. And so invoking lining and all this new all the time isn't really a fast approach. And so I think the more fundamental problem is that lining doesn't provide these sort of abstractions to write a watch task that makes it possible to sort of keep that loop running. And so while it can invoke multiple tasks in lining you cannot do it in a watch type way, which is basically also the workflow they required for their Hoplon Clojurescript style application. I hope that answers your question. Great.
Could you say something more about those pods? They're really interesting.
Okay. So they're using, I don't know if anyone has heard of Immutant. It's like a Java enterprise type application server container thing. And so in an earlier version, they didn't have this isolation on the JVM level, but they required this isolation on the Clojure level. And so the people behind Immutant wrote a library called chimdandy, which is, as far as I understood, almost the complete implementation of pods. Like everything we're using here with boot with pods is, as far as I understood, only a wrapper around chimdandy functionality. So if you're interested in pods, I recommend checking out chimdandy by, I think, Tobias Crawley, which is a Clojure library. Does that?
Yeah,
Any other question? Okay. Thanks, Martin.
Thank you.